Now let us start the next chapter, fractions. Now what is a fraction? Now for example, if you take a roti of circular in shape, now if you divide the roti into two halves, and again if you divide the each half into again two halves, so now there are four equal parts in the roti. Now here, so the two out of four equal parts, if you remove the one equal part, now this is the one part of the four equal parts of the whole roti. Now this represents 1 out of 4. So here this fraction, so now this is said to be a fraction. Now a fraction is a number representing part of a whole. So this is the whole roti. In this whole roti, we have divided it into the four equal parts. Out of four equal parts, we have considered only one part. Now this is one part of the four equal parts, so written as 1/4. Now this is said to be a fraction. Now a fraction is a number representing part of a whole. Now this whole may be a single object or it may be two or more objects, but all the parts must be equal. So whatever you divide the whole thing into some parts, but all the parts must be equal. Now in this 1/4, so here 1 is called numerator and here 4 is called the denominator. Now if you cut the one part of four equal parts, then we are left with the other three equal parts. So this represents 3 parts out of 4 equal parts. Now if you take two squares of equal sizes, now divide each square into 4 equal parts. And shade one part of the second square. Now this is whole square 1 plus. So this is one part of 4 equal parts. So this is 1/4. Now this two squares. Now this in the shaded part, the whole square. Now the shaded part of these two squares represents 1 plus 1/4. Now let us write the fraction of the shaded portion. So write the fraction representing the shaded portion. Now in the first figure, a triangle has been divided into 1, 2, 3, 4 equal parts. So out of 4 equal parts, 2 parts are shaded. So then we represent this shaded portion as the fraction 2 parts out of 4 parts. So this equals to 2/4. Now the second question. So a square has been divided into 9 equal parts. So out of 9 equal parts, see here 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 equal parts in the square. And all these 9 parts, out of 9 parts here, 8 parts are shaded. So then 8 out of 9. The next 1, 2, 3, 4, 5, 6, 7. So there are 7 equal parts, and in these 7 parts 1, 2, 3. 3 parts are shaded, so then we write 3 by 7. Next in this 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 equal parts, 9 triangles. Out of 9 triangles, so 1, 2, 3, 4. 4 triangles are shaded, then 4 out of 5. So then 1, 2, 3, 4, 5. 5 parts are not shaded. So 4 out of 5 means 4 by 9. 4 by 9 means 4 out of 9. Now let us see the next question. Shade the part portion according to the given fraction. Now there is a circle which has been divided into 6 equal parts. So out of 6 equal parts, here one part is shaded. So one part is shaded out of 6 equal parts, so we write this as 1 by 6. Now we should shade 1 by 6 means one part out of 6 equal parts. The second, now there is a triangle divided into 4 equal parts. So then here given as 1 by 4, or if it is 3 by 4, then we have to shade 3 parts out of 4. So then 1, 2, 3. Next, third one. Now there is a rectangle which is divided into 3 parts. So this is 2 by 3, means you have to shade 2 parts out of 3 equal parts. Next one, there is a square which is divided into 9 equal parts. So in this, the fraction is 4 by 9, means you have to shade 4 parts out of 9 parts. One, 2, 3, 4. Now let us see the next question. What fraction of a day is 8 hours? Now as we know that one day equals to 8 hours, Now here the fraction of 8 hours in a day. The fraction of 8 hours of a day equals to 8 hours by 24 hours. Here hours get cancelled, and here 8 ones are 8, 8 3 are 24, so then we get 1 by 3. The next question, what fraction of an hour is 40 minutes? So that is 1 hour equal to 60 minutes. So the fraction of 60 minutes of an hour equals to 60, the fraction of 40 minutes. The fraction of 40 minutes of an hour equals to 40 minutes by 60 minutes equals to minutes cancel, 0 0 cancel, we get 4 by 6, and we can cancel in 2 table, 2 2s are 4 and 2 3s are 6, so then we get 2 by 3. Now let us see the next question. Write the natural numbers from 2 to 12. What fraction of them are prime numbers? So first you have to write the natural numbers from 2 to 12. Then we should also write the prime numbers from 2 to 12. Then we have to find out what fraction of the natural numbers from 2 to 12 are prime numbers. So first, natural numbers from 2 to 12 are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now the total number of natural numbers are total number of natural numbers from 2 to 12 is 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And prime numbers from 2 to 12 are, so the prime numbers are 2, 3, then next 5. So these are the prime numbers: 2, 3, 5, then 7, 11. 2, 3, 5, 7, 11. Now the number of prime numbers from 2 to 12 is 1, 2, 3, 4, 5. So there are 5 prime numbers. Is 5. Now the fraction equals to the number of prime numbers 5 by the total number of natural numbers 11. So this is the required fraction, 5 by 11. Now let us see the next question. There are some circles, 8 circles. 1, 2, 3, 4, 5, 6, 7, 8, and out of these 8 circles, in 4 circles there are the letter, there is a letter X. What fraction of these circles have the letter X's in them? Now the number of circles with the letter X, number of circles with X equal to 1, 2, 3, 4, and the total number of circles equals to 8. Then the fraction, the required fraction equals to the number of circles with X means 4 by the total number of circles 8. So if you write this in the simplest form, we can write 4 1s are 4, 4 2s are 8. So this equals to 1 by 2. So this is either 4 by 8 or 1 by 2. Now let us discuss the next topic, the fraction on the number line. So how to represent a fraction on the number line? Now you know how to represent the natural numbers, whole numbers, and also the integers on the number line. Now fraction means it is a part of the whole. Then how to represent a fraction on the number line? So first let us represent 1 by 2 on the number line. So 1 by 2 means it is, so 1 out of 2 equal parts. Here the shaded portion represents 1 by 2 and even the unshaded portion also represents 1 by 2. Now it is greater than 0 but less than 1. So then we will draw the number line. So 0 here, minus 1, 1, 2. Now it lies between 0 and 1 because it is greater than 0, at the same time it is less than 1. So we put the midpoint between 0 and 1. So this 0 to 1, it is divided into 2 equal parts. Now this one part, so 0 to this point, so this represents 1 by 2. Next 1 by 3, 1/3. Now how to represent 1 by 3? So in a circle, so there are 3 equal parts. So out of these 3 equal parts, here one part is shaded. This represents 1/3. Now let us draw a number line. 0 minus 1, here 1. So next we can take 2, the integers. Now 1/3 also more than 0 and less than 1. So between 0 and 1 we will make 3 equal parts. So 1, 2, 3. Now this part, first part, so this is 1/3. So there are 3 equal parts. Now this part represents, so this dot 1/3, and this next one is 2/3 and it is 3/3, so that is 1. Next 1/4. So out of 4 equal parts we have to shade only one part. Now on the number line, -1, here 1. Now so here 1/4 also it is more than 0 and less than 1. So as the denominator is 4, so we divide 0 to 1 into 4 equal parts, 1, 2, 3 and 4th. And the first part, so this is 1/4, and the second part is 2/4, third part is 3/4, and it is 4/4 means 1. So in this way we can represent any fraction on the number line. Now let us see a question. Represent four by 7 and 9/11 on the number line. So first we will take 4/7. Now let us draw a number line. So first we will take 0. Now you will take each part, as the denominator is 7, so we take first part is 1/7, second part 2/7, then 3/7, 4/7, 5/7, 6/7, then 7/7. So which is equal to 1. Next 8/7, 9/7, 10/7, 11/7, 12/7. Next 13/7, 14/7, which is equals to 2. Then 15/7, 16/7. So this part is 2 and this part is 1. 7/7, this is 1. Now but we want here 4/7. So here 4/7, so this represents 4/7. Now the second one, 9/11. So here also on the number line, zero, so as the denominator is 11, first we will take 1/11, then 2/11, 3/11, 4/11, 5/11, 6/11, 7/11, 8/11, 9/11, 10/11, 11/11 means which is equals to 1. Then 12/11, 13/11, 14/11, 15/11, 16/11, 17/11, 18/11, 19/11. Then we want 9/11. So So this is a required fraction on the number line, which represents 9 by 11. Now let us go to the next topic. So that is proper fraction. Now if you take a circle which is divided into 4 equal parts, and if one part is shaded, so this represents the shaded part represents 1 by 4. So the part of the whole thing is called a proper fraction. So the part of the whole is called a proper fraction. And here the unshaded portion represents 3 by 4. So here 1 by 4, 3 by 4 are proper fractions, because either 1 by 4 or 3 by 4 represent the part of the whole circle. So then these two are also called, these two portions are called the proper fractions. Now not only the circle, if you take any other figure, if you take a rectangle, if it is divided into 1, 2, 3, 4, 5 equal parts, and if two parts are shaded, here the shaded portion represents two by, there are 1, 2, 3, 4, 5 parts, so 2 by 5, and even the unshaded part, this is also 3 by 5. So either the shaded portion or unshaded portion both represent the part of the whole. So then the part of the whole is a proper fraction, and if you observe any proper fraction, the numerator is less than the denominator. So in a proper fraction, numerator is always less than the denominator. So if you write 3 by 7, 8 by 11, 13 by 27, so the fractions in which the numerator is less than the denominator are said to be proper fractions. So whatever the fractions we take, if the numerator is less than the denominator, then it is said to be a proper fraction. So every proper fraction is a part of the whole thing. Now let us see the next fraction, that is improper fraction. Now if you observe the fractions 7 by 3, 11 by 8, 13 by 6, in all these fractions the numerator is greater than the denominator. So the fractions in which the numerator is greater than or equal to the denominator are called improper fractions. So we can write the definition as the fractions in which the numerator is greater than are equal to the denominator are called improper fractions. Now if you write, so here the numerator is greater than the denominator, so we can take 10 by 3, 15 by 11 and 18 by 7. So in all these fractions, numerator is greater than the denominator. So in this 10 is greater than 3 and here 15 is greater than 11 and here 18 is greater than 7. So if the numerator is greater than or equal to the denominator, then it is said to be improper fraction. Now next, mixed fractions. Mixed fraction. So mixed fraction means here we take one whole object and one part. So first let us take the whole circle and the other circle which is divided into 4 parts. So this is 1 plus. So if you take only 1 out of 4 equal parts, so this is 1 by 4. So this 1 by 4. Now this is said to be the mixed fraction. So mixed fraction equals to whole plus fraction, or this equals to whole plus, so that is actually proper fraction. So here whole means 1 and the proper fraction is 1 by 4. So then here mixed fraction is the combination of the whole and the part, means fraction. So now this mixed fraction 1 by 4 can be converted as the improper fraction by multiplying the denominator of the fraction with the whole number. So 4 into 1 plus 1 by 4. So this equals to 4 ones are 4 plus 1 by 4. So this equals to 5 by 4. Now you can convert any improper fraction into the mixed fraction. So here if 18 by 7 has to be converted into the mixed fraction, then we have to divide 18 by 7. So 7 2s are 14 and the remainder is 4. Then this 4 by 7. So then 18 by 7 equals to the whole number, means quotient. Then we take the remainder up by divisor. So this equals to the quotient is 2, the remainder is 4 by the divisor is 7. So in this way we can convert any improper fraction into the mixed fraction, or we can convert the mixed fraction into the improper fraction. So far we have discussed what is the fraction and how to represent the fraction on the number line, and we have also learnt the types of fractions such as proper fraction, improper fraction and also the mixed fraction. Now let us do few problems based on this. Now the first question, draw the number line and locate the fractions on it. Now the first question, so there are few fractions, so all are proper fractions, 1 by 2, 1 by 4, 3 by 4 and here 4 by 4. So this is improper fraction. Now let us draw the number line. So on the number line we take 0, so then left, and we take all equal parts. Now the first part we take, as the denominator is 4, so we take all fractions with the denominator 4. So this first one is 1/4 and 2/4, then 3/4, 4/4, then 5/4, 6/4, 7/4, 8/4, 9/4, 10/4. Now, so this 4/4 is same as 1 and 8/4 is same as 2. Now here we have to represent 1/2. So 1/2 means that is same as 2/4. Now this represents 1/2. And next 1/4. So this is 1/4. Next 3/4. So this is 3/4. Next 4/4. Next 1/8, 2/8, 3/8 and 7/8. So here also we draw the number line. So 0, as the denominator of all the fractions is 8, so then we write 1/8, 2/8. We will take all the denominators 8 here on the number line. So this 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9/8, 10/8, 11/8, 12/8, 13/8, 14/8, 15/8, 16/8 and 17/8. Here 8/8 represents 1 and 16/8 represents 2. So between 0 and 1, so there are 8 equal parts, 1, 2, 3, 4, 5, 6, 7, 8, and we want 1/8. So this is 1/8, then 2/8, then 3/8, then 7/8. Now let us see the next question. Express the following improper fractions. As mixed fractions. So we have already learnt how to convert the mixed fraction into the improper fraction and how to convert the improper fraction into the mixed fraction. So here the improper fractions are given. We have to convert them as the mixed fractions. So then first one is 20/3. So first you will divide 20/3. So then 3 6 are 18. The remainder is 2. So then we can write 20/3 improper fraction as the quotient. Then you will take the remainder up by the divisor. So quotient remainder by divisor. So this equals to quotient is 6 and the remainder is 2 by the divisor is 3. So then this can be written as 6 2/3. The next 11/5. So if we divide 11/5, so 5 2s are 10, the remainder is 1. Now 11/5 can be written as, first we take the quotient, then remainder by divisor. So then this equals to, quotient is 2, the remainder is 1 by the divisor is 5. So it is 2 1 by 5. The next one is 19 by 6. So when you divide 19 by 6, 6 3s are 18, the remainder is 1. So then we take 19 by 6 equals to quotient remainder by divisor. So this equals to, quotient is 3 and the remainder is 1 by divisor is 6. So it is 3 1 by 6. Next, 35 by 9. So when we divide 35 by 9, so here 9 4s are 36, but it is not subtracted from 35, so it is more than 35. So then we take 9 3s are 27. So 35 minus 27 is 8. So then 35 by 9 equals to quotient remainder by divisor. Here quotient is 3, remainder is 8 by divisor is 9. So it is 3 8 by 9. So by dividing the numerator by the denominator, we can express any improper fraction as the mixed fraction. Now the next question, express the following mixed fractions. As improper fractions. So here the mixed fractions are given, you have to convert them into the improper fractions. So the first question is 7 3 by 4. So then we multiply the denominator with the whole. So 4 into 7 plus we add the numerator 3 divided by 4. So this equals to 4 7s are 28 plus 3 by 4. So that is same as 28 plus 3 equals to 31 by 4. Now this is the improper fraction. Now the second one, 5 6 by 7 is the mixed fraction to be converted as the improper fraction. So here we multiply 7 and 5. So 7 into 5 plus 6 divided by 7. So this equals to 7 5 are 35 plus 6 by 7. This equals to 35 plus 6 is 41 by 7. The next question, 9 3 by 7. So this equals to 7 into 9 plus 3 by 7. So this 7 9s are 63 plus 3 by 7. So 63 plus 3 is 66 by 7. The next one is 8 4 by 9. So here also we multiply 9 and 8. 9 into 8 plus 4 by 9. Now this equals to 9 8s are 72 plus 4 by 9. 72 plus 4 is 76 by 9. Now let us see the next topic, equivalent fractions. Now let us see what are the equivalent fractions. Now let us take 3 squares of same size. Now the first square has been divided into 2 equal parts, and in this one part is shaded. The shaded portion represents 1 out of 2, so 1 by 2. Now in the second, the circle has been divided into the square, not circle, the square has been divided into 4 equal parts. So in this, 2 parts are shaded. So this represents 2 by 4. So there are 2 parts shaded out of 4 parts, so it represents 2 by 4. And in the next case, the square is divided into 6 parts, 6 equal parts. So out of the 6 equal parts, here 3 parts are shaded. So this is 3 by 6. So in the 3 cases, means in the 3 squares, the same portion of the square has been shaded. So in the first case, in the first square, so 1 part is shaded out of 2 parts. In the second, 2 parts are shaded out of 4 parts. In the third square, 3 parts are shaded out of 6 parts. But all these shaded part represents the same, but this is expressed in the different fractions as 1 by 2, 2 by 4 and 3 by 6. So these 3 fractions represent the same portion of the square. So these 3 fractions are said to be equivalent fractions. So not only 2 by 4, 3 by 6, 1 by 2. Now this fraction 1 by 2 can be written as the many equivalent fractions. So then we can state that every fraction has many, means infinitely many equivalent fractions. Then how to get the equivalent fractions of a given fraction? Now let us see how to get the equivalent fractions of the given fraction. So if you take the fraction 1 by 2 and multiply both numerator and denominator by 2, so then we get 1 2s are 2 and 2 2s are 4. And if you take 2 by 4 and multiply both numerator and denominator by the same number, so then we get another equivalent fraction. If you multiply 1 by 2 by 3 by 3, then we get 3 by 6, because 1 3s are 3 by 2 3s are 6. So when you multiply both numerator and denominator of the fraction by the same number, then we get the equivalent fractions. So to get equivalent fractions, so we multiply both numerator and denominator of the fraction by the same number. Now if you take any fraction as 3 by 4, so when you multiply both numerator and denominator of the fraction, given fraction 3 by 4 by the same number, then we will get its equivalent fractions. So then 3 by 4 equals to 3 by 4 into 2 by 2, so then we get 3 to the 6 by 4 to the 8. So 3 by 4 into, if you multiply 5 by 5, If you multiply both numerator and denominator by 5, so then we get 3 5 are 15 by 4 5 are 20. So as we multiply both numerator and denominator of the fraction by the same number, then we get its equivalent fractions. So here 6 by 8, 15 by 20 are the equivalent fractions of 3 by 4. Now let us see, is there any other way to get the equivalent fractions of the given fractions? So as we multiply both numerator and denominator by the same number, we can even divide both numerator and denominator by the same number. So then also we get the equivalent fractions. Now let us write the statement to get equivalent fractions. So we divide numerator and the denominator of the fraction by the same number. If for example 12 by 15 is given, so if both numerator and denominator are divided by same number, then we get 12 divided by 3, and here the denominator 15 is also divided by 3. So then we get 12 by 3 is 4 and 15 by 3 is 5. Now this is the equivalent fraction of the given fraction 12 by 15. So we can even divide both numerator and denominator of the given fraction by the same number to get the equivalent fractions. Now let us see an important fact regarding the equivalent fractions. So we will take some equivalent fractions and check the fact. Here in the first column we take equivalent fractions. Now the equivalent fractions, for example 3 by 4, and the equivalent fraction of 3 by 4 is 6 by 8. And in the second case we take 5 by 7 and its equivalent fraction is 10 by 14. Now let us take the product of the numerator of first fraction and denominator of second fraction. So in the next column we take product of numerator of second fraction and denominator of first fraction. The next column we take are the products equal. So let us check the products equal or not. Now in the first case, product of the numerator of first fraction. So the first fraction is 3 by 4 and the second fraction is 6 by 8. So we will take the product of numerator of first fraction means 3 into and the denominator of second fraction. So the denominator of second fraction is 8. So then 3 into 8 equals to 24. So then next column, product of numerator of second fraction. So numerator of second fraction is 6 into the denominator of first fraction, that is 4. So 6 into 4 equals to 24. So we got the same product in both the cases. So are the products equal means we can write yes. And the second example, 5 by 7 and 10 by 14. So these two are equivalent fractions. So in these two equivalent fractions also, let us check whether the two products are equal or not. Now in the first case, product of numerator of the first fraction. So numerator of the first fraction is 5 into the denominator of second fraction is 14. So 5 14s are 70. In the next case, product of numerator of second fraction. So numerator of second fraction is 10 into the denominator of first fraction, that is 7. So 10 into 7 equals to 70. So here also we got the same product. So they are equal. So if you take any two equivalent fractions, then these two products are equal. Means the product of the numerator of first fraction and the denominator of second fraction is equal to the product of numerator of second fraction and the denominator of first fraction. So this can be observed for any two equivalent fractions. Now let us see the next topic, simplest form of a fraction. Now a fraction is said to be in the simplest form or lowest form if its numerator and denominator have no common factor except 1. Now if you take the example 36 by 54, now let us check whether the numerator and denominator have any common factor other than 1. So we can observe that these two numbers 36 and 54 means numerator and denominator have a common factor 2. So then we divide both the numerator and denominator by 2, then we get 36 divided by 2 by 54 divided by 2. So then we get 36 by 2 is 18 by 54 by 2 is 27. Now still they have a common factor. Still the numerator 18 and the denominator 27 have a common factor 3. So means this is not said to be in the simplest form. So if they do not have any common factor other than 1, means if they don't have any common factor except 1, then only the fraction is said to be in the simplest form. So now it is not in the simplest form. So we divide again both numerator and denominator by the common factor 3. So then 18 divided by 3 by 27 divided by 3. So then we get 18 by 3 6 and 27 by 3 is 9. Now 6 by 9, so again they have a common factor 3. So then we divide 6 divided by 3 by 9 divided by 3. So then we get 6 by 3 is 2 by 9 by 3 is 3. Now 2 by 3, here the given fraction 36 by 54 can be written in the form of 2 by 3. So here 36 by 54, 18 by 27, 6 by 9 and 2 by 3 are the equivalent fractions of the given fraction 36 by 54. So in all these three equivalent fractions, the fraction 2 by 3, both numerator and denominator have no common factor except 1. So then this given fraction 36 by 54 can be written in the simplest form as 2 by 3. So similarly, if you take a fraction 10 by 12, so then here both the numerator and denominator have the common factor 2. So then we divide 10 by 2 and 12 also by 2. So then we get 10 by 2 is 5 and 12 by 2 is 6. Now here 5 by 6 is said to be in the simplest form. Now the shortest way to convert means the shortest way to express a given fraction in the simplest form is to divide both numerator and denominator by their HCF. So to express a given fraction in simplest form, we divide both numerator and denominator by their HCF. Now for example, (12 by 18). So this should be expressed in the simplest form. So then first we will find the HCF of 12 and 18. So then 12 ones are 12, 6 remainder. Again we take 12 as the new dividend, 6 twos are 12. So when you get the remainder 0, then the last divisor is the HCF. So your HCF is 6. Now we will divide 12 both the numerator and denominator by 6. So 12 divided by 6 by 18 divided by 6. So then we get 12 by 6 is 2 by 18 by 6 is 3. Now it is in the simplest form. So then if you express 12 by 18 in the simplest form, then we get 2 by 3. So to express a given fraction in the simplest form or in the lowest form, so we have to divide both the numerator and denominator by their HCF. So far we have learnt how to write the equivalent fractions of a given fraction and how to express the given fraction in the simplest form by finding the HCF of the numerator and denominator. Now let us do few problems based on all these concepts. Now let us see the first question. Write the fractions of the following. Are all these fractions equivalent. Now this the first figure in this circle. So there are two halves and one half is shaded. Next, in the second case, now in the second case, so in the same circle, the circle is divided into four parts, four equal parts. So in this, two parts are shaded. Next, in the third case, the circle is divided into six parts. So out of the six parts, three parts are shaded. Next, in the fourth case, the circle is divided into 8 equal parts. So in these four parts are shaded. Now let us represent each figure by using the fraction. So in this, the first case, out of two parts, one part is shaded. So this can be represented by 1 by 2. And in the second case, so there are four parts. Out of these four parts, two parts are shaded. So we can represent it by 2 by 4. And in the third case, there are six parts. Out of six parts, three parts are shaded, so we can represent it by 3 by 6. So three shaded parts out of six equal parts. In the fourth case, so 1, 2, 3, 4 parts are shaded out of 8 equal parts, so we can represent it by 4 by 8. Now let us check whether all these fractions are equivalent or not. So how can you say the two fractions are equivalent? So if both numerator and denominator are multiplied by the same number, then we get its equivalent fraction. Now let us check 1 by 2, 2 by 4 are equivalent or not. So if both numerator and denominator are multiplied by 2, so then we get 1 2 are 2 by 2 2 are 4. So we got 2 by 4. So these two are equivalent. And again 1 by 2 and 3 by 6 are also equivalent, because 1 by 2 into 3 by 3, so this equals to 3 1s are 3 by 3 2s are 6. So 1 by 2 and 3 by 6 are equivalent, and 1 by 2 and 4 by 8 are equivalent or not. So 1 by 2 into 4 by 4, so we get 1 4s are 4 by 2 4s are 8. So all the given fractions are equivalent fractions. Therefore, we can write all these fractions are equivalent. Now let us see the next question. Replace box in each of the following. By the correct number. Now in the first question, we have to replace this box by the correct number. So these two fractions are equivalent. So then we get 2 by the equivalent fraction of 2 by 7 by multiplying both numerator and denominator by the same number. So then we get 2 by 7 into, so 2 how many times make 8? So we know that 4 times, so we multiply both numerator and denominator by 4. So then we get 2 4s are 8 by 7 4s are 24. So then the equivalent fraction of 2 by 7 is 8 by 24. So when the numerator is 8, then the denominator must be 24. Now the next question, 3 by 5 equals to dash by 20. So here also these two fractions are equivalent. So you have to find the numerator when the denominator is 20. Now this 3 by 5 equals to, here 3 by 5 into, in this the denominator is given, so consider the denominator 5. 5 how many times make 20? So it is 4 times, 5 4s are 20. So we multiply both numerator and denominator by 4. So then we get 3 4s are 12 by 5 4s are 20. So when the denominator is 20, the numerator is 12. Here 3 by 5 and 12 by 20, these two are equivalent fractions. So when the denominator is 20, the numerator is 12. So the box number is 12. Next, 45 by 60 equal to 15 by dash. So here also the two fractions are equivalent. So how to get the equivalent fraction of a given fraction? Either we can multiply both numerator and denominator by the same number, or we can divide both numerator and denominator by the same number. Now then 45 by 60 equals to, now 45 divided by and 60 divided by. So what is the number must be divided? Now then 45 by 3 equals to 15. So when 45 is divided by 3, then 60 also must be divided by 3. So then 45 by 3 is 15 and 60 by 3 is 20. So when the numerator is 15, the denominator is 20. So here 45 by 60 and 15 by 20 are equivalent fractions. So when the numerator is 15, then the denominator is 20. So the box number is 20. Now let's have the next question. Find the equivalent. Find the equivalent fraction of 3 by 5 having numerator 27 and denominator 20. So here you have to find the two equivalent fractions of the given fraction 3 by 5, so that the numerator is 27 and the denominator is 20. So when the numerator is 27, then we have to find the denominator, and in the second case when the denominator is 20, then we have to find the numerator. So let us take the first given fraction 3 by 5 equals to, so your numerator is given that 27. So then we have to check 3 how many times make the numerator 27. So obviously we know that 3 9s are 27. So then 3 into 9 by, so when the numerator is multiplied by 9, then the denominator also multiplied by the same number 9. So here we take 5 into 9. Now this equals to 3 9s are 27 by 5 9s are 45. So the given fraction is 27 by 45. Next, Now the denominator is 20, so let us take the given fraction 3 by 5 equals to, now you have to check the denominator. So your denominator is 20, so then 5 how many times make 20? So it is 4 times, 5 4s are 20. Then we have to multiply both numerator and denominator by the same number. So then 3 into 4 by 5 into 4. This equals to 3 4s are 12 by 5 4s are 20. So the denominator is 20. So in the first question the numerator is 27. Now the next question, find the equivalent fraction of 36 by 48 with numerator 9 and the denominator 4. Now the given fraction is 36 by 48. Now we should get the numerator 9. So then how to get the numerator 9 in the equivalent fraction? Means 36 must be divided by some number. So what is the number? Then 36 by 4 is 9. So then 36 by 2 is 18. 36 by 3 is 12. And 36 by 4 is 9. So then we have to divide both numerator and denominator by the same number 4. So then we take 36 divided by 4 by 48 divided by 4. So then we get 36 by 4 is 9 by 48 by 4 is 12. So then the equivalent fraction of 36 by 48 is 9 by 12 when the numerator is 9. Therefore we can write that equivalent fraction of 36 by 48 is 9 by 12. And the second case, numerator, denominator 4. So 36 by 48 equals to the denominator 4. So how to get the denominator 4 in the equivalent fraction? So means 48 must be divided by some number. So what is the number to be divided? So then 48 by 12 is 4. So then we divide both numerator and denominator by the same number 12. Now 36 by 12 by 48 divided by 12. So then we get 36 by 12 is 3 by 48 by 12 is 4. So here 36 by 48 and 3 by 4 are equivalent fractions. Therefore equivalent fraction of 36 by 48 is 3 by 4. Now let us see the next question. Check whether the given fractions are equivalent. Check whether the given fractions Now the first question, 5 by 9, 30 by 54. How to check whether the given fractions are equivalent or not? So here we have to make either the numerators equal or the denominators equal. So when we make the numerators equal, if the denominators are also equal, then the two fractions are equivalent. So or if you make the denominators equal, then the numerators are also equal, then also the two fractions are equivalent. Now let us make the numerators equal in these two fractions. So the first fraction 5 by 9, and in the second fraction the numerator is 30. So how to make 5 as 30? So when 5 is multiplied by 6, then we can get 30. So in the given fraction 5 by 9, we will multiply both numerator and denominator by the same number 6. Now 5 into 6 by 9 into 6. The second fraction is same, 30 by 54. Now 5 6 are 30 by 9 6 are 54. So then 30 by 54. So when we make the numerators equal, so we got the same denominators. So the given fractions are equivalent. So therefore 5 by 9 comma 30 by 54 are equivalent fractions. Now the second question, 3 by 10 and 12 by 50. So here also we can make either numerators equal or the denominators equal. Now let us make the denominators equal. So how to make 10 as 50? So we have to multiply 10 by 5 to make the denominators equal. So then we multiply both the numerator and denominator of 3 by 10 by the same number. So 3 into 5 by 10 into 5 comma 12 by 50 is same. Now 3 5s are 15 by 10 5s are 50 comma 12 by 50. So when you make the denominators equal, then the numerators are not equal. So therefore 3 by 10 comma 12 by 50 are not equivalent. Now let us see the next question. Reduce the following fractions to simplest form. Now the first one is 48 by 60. So to reduce the given fraction to the simplest form, so we have to divide both numerator and the denominator by their HCF. So first let us find the HCF of the numerator 48 and the denominator 60. So here the larger number 60 is divided by the smaller number 48. So 48 ones are 48. Then the remainder is 12. So again we take the divisor as a new dividend 48 and the remainder as the new divisor. So then again we will do the division. 12 4s are 48. The remainder is 0. So when you get the remainder 0, the last divisor is the HCF. Now HCF of 48 and 60 is 12. Now we divide both numerator and denominator by the HCF. Now 48 by 60 equals to 48 divided by 12 by 60 divided by 12. Now then 48 by 12 is 4 and 60 by 12 is 5. So the simplest form is 4 by 5. So this can also be done by cancellation. So 48 by 60 we can cancel in 2 table or 3 table or 4 table. So if we cancel in the 4 table, 4 1s are 4, 4 2s are 8, then 4 15s are 60. Now we can cancel again 3 table, 3 4s are 12, 3 5s are 15. So then we get 3 by 5. 3 4s are 12 by 3 5s are 15. So we get 4 by 5. Next 84 by 98. So here also first we will find the HCF of both numerator and denominator. So here also the larger number 98 is divided by the smaller number 84. So 84 ones are 84. So 8 minus 4, 4, and 9 minus 8, 1. So then 84. Now 14 6 are 84. Remainder is 0. Then the HCF equals to 14. Now here also 84 by 98. So both numerator and denominator are divided by the HCF. So then 84 divided by 14 by 98 divided by 14. So 84 by 14 is 6 and 98 by 14 is 7. So the equivalent fraction is 6 by 7. So we can cancel 84 and 98. So if we cancel in the 7 table, 7 1 are 7, 1 is the remainder here, 14, 7 2 are 14, and 7 1 are 7, 2 remainder 28, 7 4 are 28. And we can cancel in 2 table, 2 6 are 12, 2 7 are 14, so we get 6 by 7. The next one is 12 by 52. So here also we will find the HCF of numerator 12 and denominator 52. Twelve fours are 48. The remainder is 4. And you will divide 12 by 4. 4 3s are 12. The remainder is 0. Now HCF equals to 4. Now 12 by 52 equals to, so divide numerator and denominator by HCF. So 12 divided by 4 by 52 divided by 4. So 12 by 4 is 3, by 52 by 4 is 13. So this can also be done by cancellation. 12 by 52, and 2 6 are 12, 2 2s are 4, 2 6 are 12, and 2 3s are 6, 2 1s are 2, 2 3 are 6. So this equals to 3 by 30. Now let us go to the next topic, the like fractions and the unlike fractions. Now let us discuss what are the like fractions and what are the unlike fractions, and we shall also discuss how to compare the fractions. Now first one, like fractions. Now if you observe the fractions 5 by 7, 2 by 7, 13 by 7, and so on. So in all these fractions we can observe one common thing, that their denominators are equal. So if the denominators are equal, then the fractions are said to be like fractions. Now the fractions with the same denominator are called like fractions. Now if the fractions do not have the same denominator, means they have the different denominators, then they are called unlike fractions. Now the fractions with different denominators are called unlike fractions. Now for example, 2 by 7, 3 by 5, 4 by 9, etc. So these are the fractions with the different denominators. So these are called unlike fractions. If the denominators are same, they are like fractions. If the denominators are not same, they are unlike fractions. Now let us see how to compare two fractions, means comparing fractions. Now for example, Raj has 3.5 rotis in his plate and Kiran has 2 1/3 rotis. Raj has 3.5 rotis in his plate and Kiran has 2 1/3 rotis in his plate. Then who has the larger, who has the more rotis in his plate? So we have to find the, means we have to compare the two fractions. Then we should say which student has the many rotis. So then here also we need to find two fractions. So for that, let us take a rectangle. The same rectangle is taken 3-4 times. So in the first case, the rectangle is divided into two parts, two equal parts, and here one part is shaded. Now this is 1 out of 2, so 1 by 2. And in the second case, the same rectangle is divided into 3 equal parts, and here one part is shaded. So this is 1/3. And in the next case, the rectangle is divided into 4 equal parts. And here the first part is shaded. Now this is 1 by 4. So if the rectangle is divided into 5 equal parts, and here also one part is shaded. Now this is 1 by 5. So when the rectangle is divided into more equal parts, then the size of each part will be reduced. Now here we can say that 1 by 2 is more than 1 by 3, and 1 by 3 is more than 1 by 4, and 1 by 4 is more than 1 by 5. But each time we cannot draw the rectangle and we cannot divide into equal parts and we cannot compare. So then how to compare the fractions? So first let us learn how to compare like fractions, then we will go to the comparison of unlike fractions. Now comparing like fractions. Now let us take the two like fractions, 2 by 5 and 3 by 5. So let us take two rectangles which are divided into 5 equal parts. Now in the first case, 2 parts are shaded out of 5 equal parts. So this is 2 out of 5, and in the second case 3 parts are shaded out of 5 equal parts. So this is 3 by. Now in which rectangle more parts are shaded? So we can easily say that in the second rectangle more parts are shaded. So we can say that the second fraction is more than the greater than the first fraction, or first fraction is less than the second fraction. So 2 by 5 dash 3 by 5. So we can write 2 by 5 is less than 3 by 5. So we can write 3 by 5 is greater than 2 by 5. So when the denominators are equal, then we can just compare the numerators, then we can put the less than symbol or greater than symbol or equal to symbol. So when the denominators are equal means when the given fractions are like fractions, means if their denominators are equal, then whatever the fraction with lesser numerator, that is less than the fraction with greater numerator, or whatever the fraction with greater numerator is greater than the fraction with lesser numerator. So let us compare other two fractions, means like fractions. So 2 by 7 dash or 3 by 7 dash 4 by 7. So these are also like fractions because their denominators are equal. So we can write that, we can compare the numerators. 3 is less than 4, so we can write 3 by 7 is less than 4 by 7. And let us take another example, 8 by 11 and 3 by 11. So here also the two fractions are like fractions because their denominators are equal. Now we can compare the numerators. So here as we know that 8 is greater than 3, then 8 by 11 is greater than 3 by 11. Now let us take the next case, comparing unlike fractions. Means if the given fractions are unlike fractions, means their denominators are not equal, then how to compare the two fractions and say which fraction is greater and which fraction is smaller. Now let us take the next case, comparing unlike fractions. So unlike fraction means their denominators are not equal. So first let us take two fractions, 1 by 3 and 1 by 5, with the same numerator but different denominators. So these two fractions are unlike fractions. Now let us take two rectangles. The first rectangle is divided into 3 equal parts, 1, 2, 3, and the second rectangle is divided into 5 equal parts, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now here one part is shaded out of 3 equal parts. So this represents 1 by 3, and here one part is shaded out of 5 equal parts. So this is 1 by 5. Now if you compare the shaded portions in two rectangles, so the 1/3, so this shaded part is more than this shaded part. So the shaded part in the first rectangle is larger than the shaded part in the second rectangle. So we can write that 1/3 is greater than 1/5. So our 1/5 is less than 1/3. Now when two fractions have different denominators and they have the same numerator, so whatever the fraction with lesser denominator is more than the fraction with larger denominator. So here also when the denominators are not equal and the numerators are equal, so when the numerators are equal, the fraction with larger denominator is less than the fraction with smaller denominator. Now if we compare other two fractions like 2/7 and 2/11, so here also these two are unlike fractions but their numerators are equal. So if you observe the numerators, they are equal, then how to compare the fractions? So when the numerators are equal, then we should compare the denominators. So whatever the fraction with lesser denominator is greater than the fraction with larger denominator. So 2/7 is greater than 2/11. And if you take 5/13 and 5/9, so here also the two fractions are unlike fractions. The denominators are equal, the denominators are not equal, but the numerators are equal. Now if we compare the denominators, here 13 is greater than 9, so then we can say that 5/13 is less than 5/9 because the fraction with larger denominator is less than the fraction with smaller denominator. So in this way we can compare any two fractions, means unlike fractions, with the same numerator. Now we should learn how to compare the unlike fractions with the different numerators. So like 2/3 and 3/4. So here either the denominators are not equal or the numerators are not equal. So this is the case of unlike fractions with the different numerators. Now let us compare the fractions, means unlike fractions with different numerators. So like 2/3 and 3/4. So to compare these two fractions, first let us write the equivalent fractions of 2/3 and 3/4. So equivalent fractions of 2/3 are, so if you multiply both the numerator and denominator by the same number, if you multiply by 2, 2 2s are 4, by 2 3s are 3 2s are 6, and 2 3s are 6, by 3 3s are 9, then 2 4s are 8, by 3 4s are 12, and 2 5s are 10, by 3 5s are 15, and so on. And let us find the equivalent fractions of 3/4. Or here also we multiply both the numerator and denominator by the same number. So 3 2s are 6, by 4 2s are 8, and 3 3s are 9, by 4 3s are 12, and 3 4s are 12, by 4 4s are 16, and 3 5s are 15, by 4 5s are 20, and so on. Now let us find the equivalent fractions with the same denominator. So here the same denominator we can find 12, so 8/12, here also 9/12. Now 2/3 comma 2/3 and 3/4, the equivalent fraction of 2/3 is 8 by 12 and the equivalent fraction of 3 by 4 is 9 by 12. So here the denominators are equal. So then we can compare the numerators 8 and 9. So we know that 8 is less than 9. So we can say that 8 by 12 is less than 9 by 12. So here also 2 by 3 is less than 3 by 4. So in this way, by finding the equivalent fractions of the given fraction, we can compare the two fractions. But sometimes it is difficult to find the equivalent fractions of the given fraction. Then how to compare two fractions? Now let us take an example, 5 by 6 and 13 by 15. So then how to compare these two fractions? So first let us find the LCM of the denominators. Means we have to find the equivalent fractions of these two fractions with the same denominator. So first let us find the LCM of the denominators, 6 and 15. So 3 2s are 6, 3 5s are 15. Then LCM equals to 3 into 2 into 5. So 3 2s are 6, 5 are 30. So then 5 by 6. And here we take 13 by 15. So here 5 by 6, if you take the denominator 6 how many times make 30? So it is 5 times. 6 5s are 30. So we multiply both the numerator and denominator by 5. So then 5 into 5 by 6 into 5. So here 13 by 15 into, now 15, the denominator 15, how many times make 30? So it is 2 times. So 13 into 2 by 15 into 2. Now this equals to 5 5s are 25 by 6 5s are 30 dash, 13 to the 26 by 15 to the 30. So here the denominators are equal. So when the denominators are equal, then we can compare the numerators. So as we know that 25 is less than 26. So 25 is less than 26. Then 25 by 30 is less than 26 by 30. So this implies 25 by 30 means 5 by 6 is less than 26 by 30 means 13 by 15. So in this way we can compare two fractions by finding the LCM of the denominators and making the two fractions like fractions. So we have to make the two fractions like fraction means their denominators must be equal. So far we have learnt what are the like fractions and what are the unlike fractions, and we have also learnt how to compare the fractions, means how to compare the like fractions and how to compare the unlike fractions. Now let us do few problems. Now the first question, write the shaded portion as fraction and write them in ascending and descending order using correct symbol, correct sign, plus greater than or less than or equal to, between fractions. Now the circle is divided into 8 equal parts. So out of these 8 equal parts, 4 parts are shaded. 2, 3, then 4 parts are shaded. In the second so in the 6 parts are shaded. So then 1, 2, 3, 4, 5, 6 parts shaded. Now in the third case, so again the circle is taken. So again it is divided into 8 equal parts. Here only one part is shaded. In the fourth case, so in this 2 parts are shaded. Now in the first case, so 1, 2, 3, 4 parts are shaded out of 8 equal parts. So it is 4 by 8. In the second case, 6 parts are shaded out of 8 parts. So it is 6 by 8. In the third case, only one part is shaded out of 8 equal parts. So it is 1 by 8. And in the fourth case, 2 parts are shaded out of 8 equal parts. So it is 2 by 8. Now if you observe all the given 4 fractions, their denominators are equal. So when the denominators are equal, so then they are like fractions. So when the given fractions are like fractions, we can easily compare the numerators and decide which fraction is smaller, which fraction is bigger. So then we will arrange them in the ascending order. So first we can take the fraction with a smaller numerator, that is 1 by 8, which is less than, then the next one is 2 by 8, less than, the next one is 4 by 8, which is less than 6 by 8. Now descending order. So first we have to take 6 by 8, which is greater than 4 by 8, which is greater than 2 by 8, which is greater than 1 by 8. Now let us see the next question. Show 2 by 6, 4 by 6, 8 by 6 and 6 by 6 on the number line. Put appropriate signs between the fractions given. So first let us represent all these on the number line. So on the number line, first we take 0, then we mark with equal intervals. So this is 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, 6 by 6, which is equals to 1, and 7 by 6, 8 by 6, 9 by 6, 10 by 6, and so on. So first let us represent 2 by 0. 0 means it is 0 by 6. So 2 by 6. So this is 2 by 6. Then 4 by 6. Now it is 4 by 6. Then 8 by 6. then 6 by 6, so it is 6 by 6. Now 5 by 6 dash 2 by 6, so here 5 by 6 lies right side to the 2 by 6, so then 5 by 6 is greater than 2 by 6. Then 3 by 6 dash 0, so 0 can be written as 0 by 6. Then here also 3 by 6 is right side to the given number, the given fraction 0 by 6, so here also 3 by 6 is greater than 0. Then 8 by 6 dash 5 by 6, so here 8 by 6 is right side to the fraction 5 by 6, so here also we can use a symbol sign greater than. 8 by 6 is greater than 5 by 6. Now we can actually compare the fractions. So these fractions are like fractions because their denominators are equal, so we can compare the numerators 5 and 2. So as 5 is greater than 2, 5 by 6 greater than 2 by 6. Here 0 can be written as 0 by 6, so the denominators are equal, 3 greater than 0, so then 3 by 6 greater than 0 by 6. Here also the denominators are equal, 6 and 6, so we can compare the numerators 8 and 5. 8 is greater than 5, so 8 by 6 is greater than 5 by 6. Now let us solve the next question. Compare the fractions and put an appropriate sign. Now the first question, 3 by 6 dash 5 by 6. So when the denominators are equal, now the fraction with lesser numerator is less than the fraction with larger numerator. Now if you compare the numerators here, 3, 5, so 3 less than 5, so then we can say that 3 by 6 less than 5 by 6. Now in the second question, 1 by 7 dash 1 by 4. So but here the numerators are equal. If the numerators are equal, now the fraction with larger denominator is less than the fraction with smaller denominator. Now here 1, 1 both numerators are equal. So when you compare the denominators 7 and 4, 7 greater than 4, but 1 by 7 is less than 1 by 4. Next 4 by 5 and 5 by 5. So in these two fractions the denominators are equal. So when you compare the numerators 4 less than 5, so then 4 by 5 is less than 5 by 5. Next 3 by 5 dash 3 by 7. So here also both numerators are equal. So when you compare the denominators 5 less than 7, but 3 by 5 is greater than 3 by 7. Next, fill in the blanks. With less than, greater than or equal to sign. Now in the first question, 1 by 2 dash 1 by 5. So here the numerators are equal. So when you compare the denominators, now the first question 1 by 2 dash 1 by 5. So in this the numerators are equal. So then actually 2 less than 5, but here 1 by 2 is greater than 1 by 5. Next 2 by 4 dash 3 by 6. If we write 2 by 4 in the simplest form, so we get 1 by 2, and even 3 by 6 in the simplest form 1 by 2. So these two fractions are equal. So here also, so these two are equal. Next 3 by 5 dash 2 by 3. Here the denominators are not equal, the numerators are not equal, and even they are in the simplest form. So then how to compare these two fractions? So then let us do one thing. So we will do the cross multiplication as 3 into 3 dash 2 into 5. Now 3 3s are 9 dash 2 5s are 10. So here 9 less than 10. So then 3 by 5 is less than 2 by 3. Next, 3 by 4 dash 2 by 8. Now this 3 by 4 is already written in the simplest form. So this is 3 by 4 dash, if you write 2 by 8 in the simplest form, so this is 1 by 4. Now if you write 2 by 8 in the simplest form, so we get 1 by 4. Now when you observe the denominators, so the denominators are equal. So then 3 is greater than 1, so then 3 by 4 is greater than 1 by 4. So here also 3 by 4 is greater than 2 by 8. Next, 7 by 9 dash 3 by 9. So here the denominators are already equal. So when you compare the numerators, 7 is greater than 3. So then 7 by 9 is greater than 3 by 9. Next, 6 by 10 dash 4 by 5. So here the 6 by 10, if you write in the simplest form, we get 3 by 5 dash 4 by 5. So then when the denominators are equal, so then you can compare the numerators. 3 is less than 4, so then 3 by 5 is less than 4 by 5. So even 6 by 10 is less than 4 by 5. Next, 3 by 4 dash 7 by 8. So here the numerators are not equal or the denominators are not equal. So then we can write the equivalent fraction of 3 by 4 with the denominator 8. So then multiply both numerator and denominator by 2. So then 3 2s are 6 by 4 2s are 8 dash 7 by 8. Now the denominators are equal. So then 6 less than 7, then 6 by 8 less than 7 by 8. So even 3 by 4 is less than 7 by 8. Next, 5 by 7 dash 15 by 21. Here 5 by 7 is in the simplest form. 5 by 7 dash, if you write 15 by 21 in the simplest form, so we can write 5 by 7. 3 5s are 15, 3 7s are 21. So we get 5 by 7. So here 5 by 7 equal to 5 by 7. So here 5 by 7 is same as 15 by 21. So these two are equivalent fractions. Now let's solve the next question. The following fractions represent just 3 different numbers. Separate them into 3 groups of equivalent fractions by changing to the simplest form. Now all the different fractions represent only 3 different numbers. So then by changing each one to its simplest form, so we should separate them. So the first fraction is 2 by 12. So if you write the equivalent fraction of 2 by 12, so if both numerator and denominator are divided by 2, so then 2 divided by 2 by 12 divided by 2. So then we get 1, 2 divided by 2 is 1 by 12 divided by 2 is 6. So this is 1 by 6. Next, 3 by 15. So here both numerator and denominator are divided by 3. So then 3 divided by 3 by 15 divided by 3. So this equals to 3 by 3 is 1 by 15 by 3 is 5. Next, 8 by 50. So here both are divided by 2. Both numerator and denominator are divided by 2. So then 8 divided by 2 by 50 divided by 2. So this equals to 8 by 2 is 4 by 50 by 2 is 25. So it represents 4 by 25. Now here we got 3 different numbers. Now let us check the other 3 fractions also. So 16 by 100. So if both numerator and denominator are divided by 4. So then 16 divided by 4 by 100 divided by 4. So 16 by 4 is 4 by 100 by 4 is 25. So this is 4 by 25. Next, 10 by 60. So this both numerator and denominator are divided by 10. So 10 divided by 10 by 60 divided by 10. So we get 10 by 10 is 1 by 60 by 10 is 6. So this is 1 by 6. Next, 15 by 75. So if both numerator and denominator are divided by 15, so then 15 by 15 divided by 75 by 15. So then 15 divided by 15 is 1 by 75 by 15 is 5. So this is 1 by 5. Now let us do the next question. Find answers to the following. Write and indicate how you solve them. The first question is 5 by 9 equal to 4 by 5. So when you compare both the fractions, either the denominators are not equal or the numerators are not equal. So first let us make the denominators equal. So the LCM of 9 and 5 is 45. So then 5 by 9 can be written as 5 by 9 into, to make the denominator 45, so 9, the denominator 9 should be multiplied by 5. So even the numerator also multiplied by 5. So then we get 5 5s are 25 by 9 5s are 45. So then 4 by 5 equals to 4 by 5 into, so to make the denominator 45, 5 should be multiplied by 9. So even the numerator also multiplied by 9. So then we get 4 9s are 36 by 5 9s are 45. So both the denominators are equal, but numerators are not equal. So we can say that no, 5 by 9 is not equal to 4 by 5. Next, is 4 by 5 equal to 16 by 20? So here 4 by 5 can be written as, in the simplest form also, 4 by 5. So then 16 by 20, if you write in the simplest form, so 16 divided by 4 by 20 divided by 4. If both numerator and denominator are divided by 4, so then we get 16 by 4 is 4 by 20 by 4 is 5. So yes, the two fractions are equal. 4 by 5 equal to 16 by 20. Now let's see the next question. Kavita read 25 pages of a book containing 100 pages. Lalita read 2 by 5 of the same book. Who read less? So here the first person, Kavita read 25 pages of a book containing 100 pages, means out of 100 pages she read only 25 pages. So the fraction of book read by Kavita equals to 25 out of 100. So then if you write the simplest form, so we get, if you divide both numerator and denominator by 5, so we get 25 divided by 5 by 100 divided by 5. So we get 25 by 5 is 5 by 100 by 5 is 20. Now fraction of the book read by Lalita equals to 2 by 5. So when you compare the denominators, so here the denominators are not equal. So then we write 5 by 20 as, in the simplest form, as 1 by 5 ones are 5 and 5 fours are 20. So we write 1 by 4. So even though we cannot compare both the fractions 1 by 4 and 2 by 5, so because their denominators are not equal or the numerators are not equal, so then 1 by 4, 2 by 5. So to make the denominators equal, so we multiply numerator and denominator of 1 by 4 by 5. So then we get 1 5s are 5 by 4 5s are 20. and here 2 by 5 means we can take the same fraction 5 by 20 as it is, and to make the denominator 2 by 5 as 20, so we multiply both by 4, so 2 4s are 8 by 5 4s are 20. So then 2 by 5 is same as 8 by 20, and 25 by 100 is same as 5 by 20. So when you equate the denominators 20 20 and you compare the numerators 5 and 8, so here 5 less than 8, so 5 by 20 less than 8 by 20. So then Kavita read less, so I can write that therefore Kavita read less. So far we have learnt the like fractions, unlike fractions, and the comparing fractions, such as comparison of like fractions and the comparison of unlike fractions, and we have done some problems related to the comparison of fractions. Now let us learn something more regarding the fractions, so that is the addition and subtraction of fractions. So first let us learn the addition of fractions, then the subtraction of fractions. Addition and subtraction of fractions. Now for example, Madhu has an apple and he divided the apple into 5 equal parts, and 2 parts he has given to his friend Saurabh, so he has given to Saurabh 2 equal parts, and he gave 3 parts to his another friend Ramesh. Then how to add the fraction of the apple got by Saurabh, Ramesh individually, and what is the total part of the apple given to the 2 friends. So then here we need to add the 2 fractions. So there are some situations in our day-to-day life, so where we can add the fractions or where we can subtract the fractions. Now for example, let us take a rectangle which is divided into 1 2 3 4 5 parts. So out of these 5 parts, the rectangle is divided into 5 equal parts. So in these 5 parts, 2 parts are shaded, now 2 parts out of 5 parts are shaded and the 3 parts are not shaded. So when we write 3 by 5, so when the denominators are equal, so then we can add the numerators 2 plus 3 by keeping the same denominator 5. So then this equals to 2 plus 3 is 5 by 5. Now even when we subtract the fractions, means 3 by 5 minus 2 by 5. So then when the 2 fractions are like fractions, means their denominators are equal, so then we can simplify both the numerators. 3 minus 2 by 5, so this equals to 3 minus 2 is 1 by 5. So when the denominators are equal, so we can simply add the numerators by keeping the same denominator, and we can simply subtract the numerators keeping the same denominator. Now for example, 1 by 7 plus 3 by 7. So here also the denominators are equal, so 1 plus 3 by 7. So this equals to 4 by 7. Next, 5 by 11 minus 3 by 11. So here also the denominators are equal. So then we can subtract the numerators. 5 minus 3 by 11. So this equals to 5 minus 3 is 2 by 11. Now how to add or subtract the fractions, so in which the denominators are not equal, means the fractions are unlike fractions. Now let us take an example. 5 by 6 plus 7 by 9. So the denominators are not equal, means they are unlike fractions. So then here we cannot add the numerators simply. So then first you have to make the denominators equal, means you have to convert the fractions as like fractions. So then first you will find the LCM of 6 and 9. 2 3s are 6, 9 is the same. Then 3 1s are 3, 3 3s are 9. So again 1 same, 3 1s are 3. So LCM equals to 2 into 3 into 3. So 2 3s are 6, 6 3s are 18. So 18 is the LCM. So then we get 5 by 6 into, now 6 how many times make 18? 3 times. So we multiply both numerator and denominator by 3 plus 7 by 9. Here the denominator is 9. 9 2 times LCM 18. So multiply both numerator and denominator by 2. So then we get 5 3s are 15 by 6 3s are 18 plus 7 2s are 14 by 9 2s are 18. Now the denominators are equal. Now we can add the numerators. 15 plus 14 by 18. So this equals to 15 plus 14 is 29 by 18. So if you write the improper fraction in the mixed fraction, if 29 is divided by 18, so 18 ones are 18. So 9 minus 8 1, 2 minus 1 1. So 11 by 18. So this equals to 111 by 18. Now let us see an example for subtraction. Three by 4 minus 1 by 6. Now here also the given fractions are not like fractions, they are unlike fractions, means the denominators are not equal. So first let us make the denominators equal. For this we have to find the LCM of the denominators. The LCM of the denominators 4 and 6. Now 2 2s are 4, 2 3s are 6. Now LCM equals to the product of the prime factors 2 into 2 into 3. So 2 2s are 4, 4 3s are 12. Now this equal to 3 by 4 into, here 4 3 times 12. So 3 3 minus 1 by 6 into 6 2 times 12. So 2 2. So this equals to 3 3s are 9 by 4 3s are 12 minus 1 2s are 2 by 6 2s are 12. So this equals to 9 minus 2, 7 by, or we can write when the denominators are equal. Now we can subtract the numerators. 9 minus 2 by 12. So 9 minus 2 is 7 by 12. Now let us do a few problems based on addition and subtraction of the fractions. Now the first question. Write the following as addition or subtraction. Now the first one is a rectangle is divided into 1, 2, 3, 1, 2, 3, 4, 5 equal parts. So in this two parts are shaded. So in this two parts are shaded, plus, so there is another rectangle. One, two, three, four, five. So in this again there are 5 equal parts. So in this one part is shaded. So there is another rectangle. Two, three, four, 5 parts. So in these 3 parts are shaded. Now, when you observe the first 2 rectangles, so this is 2 out of 5 parts, so it is 2 by 5, plus one part is shaded out of 5 parts, so 1 by 5. So then we get 3 parts shaded out of 5 parts. So then the first rectangle plus second rectangle equals to the third rectangle with shaded parts. Now the second question. Now there is a circle divided into 4 parts. So in this one part is shaded, and there is another circle divided into 4 parts, but in this 2 parts are shaded. Now in the first circle all the 4 parts are shaded. In the second circle 2 parts are shaded. In the third circle two parts are shaded. Now this, so 4 out of 4 parts are shaded, so this can be written as 4 by 4, and here 2 by 4, 2 are shaded. So then we get the other 2 shaded parts, so 2 by 4. Now 4 by 4 minus 2 by 4 equals to 2 by 4. So then we can use the subtraction. The first circle minus second circle equals to the third circle. So this represents 4 by 4, and this represents 2 by 4, and this represents other 2 by 4. So then 4, when the denominators are equal, 4 minus 2, 2 by 4. Now let us solve the next question. Solve the given fractions. So when you take the first question, 1 by 18 plus 1 by 18, so the denominators are equal. So when the denominators are equal, we can add the numerators 1 plus 1 by keeping the same denominator as 18. So then this equals to 1 plus 1, 2 by 18. Now if you write the fraction 2 by 18 in the simplest form, so we get 2 ones are 2 by 2 nines are 18. So then this equals to 1 by 9. Now the second question, 1 by 22 plus 21 by 22. So here also the denominators are equal. Now we can add the numerators 1 plus 21. So this equals to 1 plus 21 is 22 by 22. So if we cancel the 22 table, 1s are 22 1s are. So 1 by 1 means 1. Next, 12 by 15 minus 7 by 15. So here also the denominators are equal. So we can subtract the numerators 12 minus 7, keeping the denominator, same denominator as 15. So 12 minus 7 is 5 by 15. So 5 1s are 5 and 5 3s are 15. So we get 1 by 3. Next, 3 minus 12 by 5. So here the denominator we can think as 1. Denominators are not equal. So then we multiply 3 into 5 by 1 into 5 minus 12 by 5. So 3 5s are 15 by 5 minus 12 by 5. So then we get 15 minus 12 by 5. So this equals to 15 minus 12, 3 by 5. Now let us see the next question. Fill in the missing fractions. Fill in the missing fractions. Now the first one is 7 by 10 minus dash equals to 3 by 10. So then 7 by 10 minus, so 7 minus what equal to 3, means what should be subtracted from 7 to get the result 3. So we know that 4 should be subtracted keeping the same denominator 10. So then 7 by 10 minus 4 by 10 equals to 3 by 10. So or we can write 7 minus 4 by 10 equals to 3 by 10. So the blank is 4 by 10. Next, dash minus 3 by 21 equals to 5 by 21. So what must be subtracted? From what 3 must be subtracted? So dash minus 3 by 21 equals to 5 by 21. Now we know that 8 minus 3 is 5. So then we write here 8. So then 8 by 21 minus 3 by 21 equals to 5 by 21. So the blank is 8 by 21. So 8 minus 3 is 5. Next, dash plus 5 by 27 equals to 12 by 27. So dash plus 5 by 27 equals to 12 by 27. So what must be added to 5 to get the result 12? So we know that 7 must be added. So we write 7 by 27 plus 5 by 27 equals to 12 by 27. So here the blank is 7 by 27. Now let us see the next question. Javed was given 5 by 7 of a basket of oranges. So what fraction of oranges was left in the basket? So there are some oranges in the basket, but he has got 5 by 7 of the basket of oranges. Then how many, means what fraction of the oranges was left in the basket? Now first let us write the statement. Now the fraction of oranges given to Javed equals to 5 by 6. Now the fraction of left in the basket equals to the whole oranges, means whole basket means 1 minus 5 by 6. So this equals to 1 can be written as 6 by 6 minus 5 by 6. So this equals to 6 minus 5 by 6. So this equals to 1 by 6. Now 1/6 of oranges was left in the basket. Now let us see the next question. Solve means add the fractions 3 by 10 plus 7 by 15. So here the denominators are not equal, means they are not like fractions. Then first you have to make them the denominators equal. So then means you have to make them the like fractions. So let us find the LCM of the denominators. 10 and 15. So 2 5s are 10 and 15 same. Then 5 1s are 5, 5 3s are 15. So LCM equals to 2 into 5 into 3, that is 2 5s are 10, 10 3s are 30. So then we get 3 by 10 into the denominator 10 3 times 30, so we multiply both numerator and denominator by 3 plus 7 by 15. Here the denominator 15 2 times becomes 30, so we multiply both numerator and denominator by 2. So this equals to 3 3s are 9 by 10 3s are 30 plus 7 2s are 14 by 15 2s are 30. Now the denominators are equal, so we can add the numerators. So then 9 plus 14 by 30. Now this equals to 14 plus 9 is 23 by 30. Next, 2 by 3 plus 3 by 4 plus 1 by 2. So here also the given fractions are not like fractions, so they are unlike fractions, means their denominators are not equal. So we should make them like fractions, means we have to make the denominators equal. So let us find the LCM of the denominators. 3 4 2. So 2 3s, 2 2s are 4, 2 1s are 2. Then LCM equals to 2 into 3 into 2. So 2 3s are 6, 6 2s are 12. LCM is 12. Now let us take the first fraction 2 by 3 into the denominator 3 4 times 12. So we write 4 by 4, means multiply numerator and denominator by 4 plus 3 by 4 into, now here the denominator 4 3 times 12, so we multiply numerator and denominator by 3 plus 1 by 2 into, here the denominator 2 6 times 12, so then multiply both numerator and denominator by 6. So this equals to 2 4s are 8 by 3 4s are 12 plus 3 3s are 9 by 4 3s are 12 plus 1 6 are 6 by 2 6 are 12. Now this equals to, now the denominators are equal, so then 8 plus 9 plus 6, keeping the same denominator 12. Now 8 plus 9 17, 17 plus 6 23 by 12. So if you write 23 by 12 in the mixed fraction, 12 ones are 12, the remainder is 1, 2 minus 1, 1, 11, so 11 by 12. So this equals to 111 by 12. Now let us add the mixed fraction. So then how to add the mixed fractions? While adding the mixed fractions or while subtracting the mixed fractions, so first we can take the whole numbers and add, then we can add the fractional parts, or we can convert them into the improper fractions and we can add them. So first let us convert the given mixed fractions into the improper fractions. So then 3 4s are 12 plus 2 14 by 3 plus here 4 3 are 12 plus 1 13 by 4. Now the LCM of 3 and 4. So 2 3 2 2s are LCM is 2 3 are 6, 2 are 12. So then 14 by 3 into, so 3 4 times 12, so we multiply both numerator and denominator by 4 plus 13 by 4. Here 4 3 times 12, so then 3 by 3. 14 4s are 56 by 12 plus 13 3s are 39 by 12. So this equals to 56 plus 39 by 12. So this equals to, so when the denominators are equal, we can add the numerators keeping the same denominator. So then 9 plus 6 is 15, 1 plus 3 4, 4 plus 5 9, 95 by 12. So if you write 95 by 12 as a mixed fraction, 12 sevens are 84. So then 5 minus 4 is 1, 9 minus 8 is 1, so 11 by 12. Now this equals to 7, 11 by 12. Now the same thing, the same mixed fractions we can add in another way. 4 2 by 3 plus 3 1 by 4. So first we can add the whole number parts. 4 plus 3 plus the fraction parts 2 by 3 plus 1 by 4. Here 4 plus 3 is 7 plus, now these two fractions are not like fractions, so the LCM of 3 and 4 is 12. So then here 2 by 3 into 3 4 times 12, so 4 by 4 we take, plus 1 by 4 into, here 4 3 times 12, so we take 3 by 3. So this equals to 7 plus 2 4s are 8 by 3 4s are 12 plus 1 3s are 3 by 4 3s are 12. Now this equals to 7 plus, here 8 plus 3 by 12. So this equals to 7 plus 8 plus 3 is 11 by 12. This can be written as 7 11 by 12. So if you add in any method, we get the same answer as 7 11 by 12. Now the next one is the subtraction of two fractions. So the procedure is same while adding or while subtracting the fractions. First you have to make the denominators equal, means you should convert them like fractions. So for that we need to find the LCM of the denominators 3 comma 2. So the LCM is their product only. So then LCM is 3, 2 into 3 is 6. Now we take 4 by 3 into 3 2 times 6, so we take 2 by 2 minus 1 by 2 into 2 3 times 6, so we take 3 by 3. Now 4 to the 8 by 6 minus 3 to the 6, then minus 1 3 are 3 by 2 3 are 6. Now this equals to, so when the denominators are equal, we subtract the numerators. 8 minus 3 by 6, now this equals to 5 by 6. Now let us solve the next question. Fill in the boxes. Dash minus 5 by 8 equals to 1 by 4. So whenever you subtract a number from the given number, for example 5 minus 3 equals to 2, then 5 can be written as the sum of these 3 and 2, so 2 plus 3. So here also the box is the sum of 1 by 4 and 5 by 8, so 1 by 4 plus 5 by 8. Now here the denominators are not equal, so we find the, first we make the denominators equal. The LCM of 4 and 8, 2 2s are 2 4s are 2 1s are 2 2s are, so LCM equals to 2 into 2 into 2, so 2 2s are 4, 4 2s are 8 is the LCM. So then 1 by 4 into 4 2 times 8, so we take 2 2 minus plus 5 by 8, so 8 1 time 8, so we take 1 by 1. So then 1 2s are 2 by 4 2s are 8 plus 5 1s are 5 by 8 1s are 8. So when the denominators are equal, we should add the numerators. 2 plus 5 by 8, so this equals to 7 by 8. So the blank is 7 by 8. Next, 1 by 2 minus dash equals to 1 by 6. Now for example, 5 minus 2 equals to 3. So then if you want to find the number 2, then in place of 2 equals to blank is there. So then to find this blank we have to subtract 3 from 5. So then the blank equals to this x equals to this 5 minus 3. So here also the blank can be obtained by subtracting 1 by 6 from 1 by 2. So this equals to 1 by 2 minus 1 by 6. Now this equals to the LCM of 2 and 6. 2 1s are 2 3s are. So LCM equals to 2 into 3 equals to 6. Now 1 by 2. So 2 3 times 6. So we take 3 by 3 minus 1 by 6. So here 6 1 times 6. So we take 1 by 1. So this equals to 1 3 are 3 by 2 3 are 6 minus 1 1s are 1 by 6 1s are 6. Now 3 minus 1 by 6. So this equals to 2 by 6. And we can write in the simplest form as 2 1s are 2, 2 3 are 6. So this equals to 1 by 3. So the blank is 1 by 3. Now let us see the next question. Complete the addition subtraction box. Now in the box, so 4 fractions are given, so we have to find the sum of these 2 fractions and fill up this box, and the sum of 1 by 3 and 1 by 4 should be filled in this box. Now the subtraction, now the difference of 1 by 2 and 1 by 3 and the difference of 1 by 3 and 1 by 4. So first let us add the given 2 fractions, 1 by 2 plus 1 by 3. Now the LCM of 2 and 3 is 6. So we take 1 by 2. We multiply both by 3 by 3 plus 1 by 3 into 2. So then 1 3s are 3 by 2 3 are 6 plus 1 2 are 2 by 3 2 are 6. So this equals to 3 plus 2, 5 by 6. So this is 5 by 6. Next, 1 by 2 minus 1 by 3 should be filled in this box. So 1 by 2 minus 1 by 3. So here also we follow the same procedure. So 1 by 2 into 3 minus 1 by 3 into 2 into 2. So then 1 3 are 3 by 6 minus 2 by 6. So 3 minus 2, 1 by 6. Next, 1 by 3 plus 1 by 4. 1 by 3 plus 1 by 4. So this equals to 1 by 3 into 4 into 4. The LCM of 3 and 4 is 12. So 3 4 times 12. So we multiply numerator and denominator by 4 plus 1 by 4 into here 4 3 times 12. So we take 3. So this equals to 1 4s are 4 by 12 plus 1 3s are 3 by 12. So then 4 plus 3 is 7 by 12. So in this 7 by 12. Next, 1 by 3 minus 1 by 4. One by 3 minus 1 by 4 equals to 1 into 4 by 3 into 4 minus 1 into 3 by 4 into 3. So this equals to 1 4s are 4, by 12 minus 1 3 are 3 by 12. So here 4 minus 3 is 1 by 12. Next, so this box should be filled by adding these two fractions or by subtracting. So if you add the two fractions 1 by 6 plus 1 by 12, so then we get one answer here. And if you subtract 7 by 12 minus 5 by 6, so we'll get the different answer. So then if you add these two fractions 1 by 6 plus 1 by 12, so 1 by 6 can be written as 2 by 12 plus 1 by 12. So this equals to 2 plus 1 by 12. So this equals to 3 by 12. And 3 by 12 can be written as 1 by 4. So it is 1 by 4. And let us subtract 7 by 12 minus 5 by 6. So 5 by 6 minus 7 by 12. Here 5 by 6 can be written as 2 5s are 10 by 2 6 are 12 minus 7 by 12. So this equals to 10 minus 7 by 12. So this equals to 3 by 12. So this is 1 by 4. So we got the same answer in the two cases. So that is 1 by 4. So by adding these two fractions or by subtracting 7 by 12 from 5 by 6, we got the same answer, that is 1 by 4. Now let us solve few problems, verbal problems based on the addition and subtraction of fractions. Now the first question, Naina was given 1 by 2 piece of cake and Najma was given 1/3 piece of cake. Find the total amount of the cake was given to both of them. So here the Naina was given 1 by 2 piece of cake and Najma was given 1 by 3 piece of cake. So we have to find the total amount of the cake given to both of them. Now let us write the statements for the question. Part of cake given to Naina equals to 1 by 2. So if you write this in the improper fraction, so we can write 2 ones are 2 plus 1, 3 by 2. So then part of cake given to Najma equals to 1 by 3. So 3 ones are 3 plus 1 4 by 3. Now to find the total amount of the cake given to both of them, so we have to add these two fractions 3 by 2 and 4 by 3. Total amount of cake given to both of them equals to 3 by 2 plus 4 by 3. Now the LCM of 2 and 3 is 6. So then 3 by 2 into 2 3 times 6, so we multiply by 3 plus 4 by 3 into 3 2 times 6, so 2 and 2. Now 3 3s are 9 by 2 3s are 6 plus 4 2s are 8 by 3 2s are 6. Now this equals to, so the denominators are equal, we can add the numerators. 9 plus 8 by 6, 17 by 6 If you write the mixed fraction, 6 2s are 12, the remainder is 5, so 5 by 6. So this is 2 5 by 6. Therefore 2 5 by 6 of the cake was given to both of them. Therefore we can write 2 5 by 6 of cake was given to both of them. Now let us see the next question. Zaidev takes 2 1/5 minutes to walk across the school ground and Rahul takes 7/4 minutes to do the same. Then who takes less time and by what fraction? So first let us write the given question as the statements. So the first statement is, so the time taken by Zaidev is 2 1/5 minutes. Two 1/5 minutes. Now this, if you write in the mixed fraction as the improper fraction, so we get 5 2s are 10 plus 1 11/5 minutes. Next, time taken by Rahul equals to 7/4 minutes. Now if you want to find who takes less time, so then we cannot find here because the denominators are not equal. So then let us make the denominators equal. So then 11/5, so this first Zaidev and here Rahul we will take. Now 11/5, here 7/4. So here the LCM of the denominators 5 and 4 is 20. So we multiply 4/4. Here 4 5s are 20, so 5/5. Then 11 4s are 44 by 5 4s are 20, and here 7 5s are 35 by 4 5s are 20. The time taken by Zaidev is 44/20 minutes. At the same time, the time taken by Rahul is 35/20 minutes. Now we will find the difference. So here we can find that Rahul takes less time because when the denominators are equal, so 35 is less than 44. So then we can say that Rahul takes less time when compared with Zaidev. Then we have to find out by what fraction. So then we will find the difference of these two. So then 44/20 minus 35/20. So this equals to 44 minus 35/20. So this equals to 44 minus 35 is 9/20 minutes. Therefore Rahul takes less time than Zaidev by 9/20 minutes. To walk across the school ground. To walk